On this channel, we provide useful programming information with practical code examples. This time, we will talk about web workers in TypeScript. You can learn about the concept of web workers and various usage tips with examples. Enabling subtitles will make the code descriptions easier to understand. In TypeScript, a worker is a mechanism for performing processing in the background, separate from the main thread, leveraging the JavaScript Web Workers API. This allows heavy computations and asynchronous tasks to be executed without affecting the operation of the user interface. A worker operates in parallel with the main thread, UI thread, and can exchange data between threads via messages. Even in TypeScript, you can use worker while writing type-safe code. The basic usage of a worker is as follows. Creating a worker. Create a worker instance and execute the specified script. Normally, the script is defined in a separate file. Message exchange. Send and receive messages between the main thread and the worker thread using postMessage and onMessage. Let's look at an example of a basic worker implementation. The worker script, worker TS, looks like the following. The script that uses the worker, main.ts, looks like the following. In this example, worker TS runs in a separate thread, calculates the sum of num1 and num2, and returns it to the main thread. The main thread receives the result and outputs it to the console. When you specify type module, the worker script is interpreted as an ES module, allowing you to use import and export. This allows you to handle module structures without using the traditional import scripts. In TypeScript, define data types to ensure type-safe interaction during message sending and receiving. By specifying the type parameter of message event, you can clearly define the type of data to receive. This allows data to be exchanged with type safety. When using worker in TypeScript, bundlers like Webpack or Vite may be required. By using these tools, you can properly bundle the worker script and make it available from the main thread. For example, when using Vite, use import meta.url to correctly import the worker. This ensures that the bundled worker script is loaded correctly, enabling processing leveraging worker. There are several points to note regarding messaging and concurrency. Data copying. When sending and receiving messages between the main thread and the worker thread, data is copied. When dealing with complex data such as objects, efficiency needs to be considered. Frequently exchanging large amounts of data can degrade performance. Transferable objects. Some objects, such as ArrayBuffer, are called transferable objects. Transferable objects can be transferred to the worker instead of being copied during messaging. This allows you to avoid the overhead of data copying. By passing buffer as the second argument to worker postmessage, the buffer is transferred to the worker instead of being copied. After this, the buffer on the main thread becomes empty, with byte length 0, and can only be used by the worker. The worker should be terminated after use to minimize memory consumption. You can terminate a worker by using the terminate method. This code terminates the worker by using the terminate method. If an error occurs within a worker, you can handle the error using the onError event. This code catches and handles errors that occur inside the worker using the onError event. By using worker in TypeScript, you can execute heavy tasks in the background while keeping the main thread smooth. By utilizing type definitions, message exchanges can also be done in a type-safe manner. By paying attention to data exchange and thread management, you can achieve performance improvements and efficient concurrency. The source code for this video can be downloaded from the official website. If you like, please visit the URL in the description to aid your learning. If you enjoyed this video, please consider subscribing to the channel and giving it a thumbs up. Thank you for watching.